Okay, let's go over 109B, understanding heat and temperature. Uh, in a hot cup of coffee, vibrating more. What has more thermal energy? Giant iceberg, because even though each molecule has a little bit of energy, overall there's lots of molecules. One molecule in iceberg and one from the coffee. Coffee has more energy. Number four, iceberg's got more because, again, it's got more total molecules. Let's see, most rapidly expanding gases, steam, right? Spreads out. Liquids would be in the middle, solids least rapidly expanding. Uh, a thermometer has that open space so that the fluid can flow into it as it expands. And a thermometer measures its own temperature, yeah, because it measures the temperature of the glass or the metal that makes up the actual thermometer itself, or plastic, I guess. When he's punching the thermometer, this is what we were talking about. This is the molecules vibrating and bumping into each other. It'd be like in a mosh pit. Somebody bumps into somebody else and sends them moving. And then they bump into somebody else and send them moving. Let's see, number 9. Right, it's called centigrade because it's 100 gradients. Centi, like century, 100, and grade is a gradient, or the little lines that are on there. You could kind of call centimeters centigrade because that's also 100 little lines on a ruler. What's more accurate? Well, Fahrenheit has more gradients for the same amount of space than centigrade does. So you could say Fahrenheit's more accurate. You're probably more comfy with Fahrenheit, although the centigrade Celsius system is simpler to use because it's out of 100. So that was the first thing. Next one, all matter is made of continuous moving molecules and atoms. Although, since things are moving, that's kinetic energy. Thermal energy is equivalent to kinetic energy, and it's measured in joules, right? So joules of energy, just like all the other energies. You should have a definition of temperature that you found that's related to the kinetic energy of molecules, how much they're vibrating. That's what temperature is. So higher temperature, more vibration. Lower temperature, less vibration. On the Celsius scale, boils at 100, freezes at 0. Fahrenheit boils at 212, freezes at, let's see, what is that, 32. And on the Kelvin scale is like the Celsius scale, but shifted by 273. And so, let's see, water boils at 373 and it freezes at 273. And then down at the very bottom of the Kelvin scale is what's called absolute zero. It's where nothing moves. And absolute zero is where nothing vibrates at all. We never get there, except we get close in a lab. Direction of spontaneous energy transfer is always from higher energy to lower energy. Think of water. If you pour some water on a hill, it's always going to roll downhill, right? It's always going to try and spread out, right? You wouldn't pour water and it wouldn't like stay in a bowl shape. It would always go flat and spread out. Heat, the flow of energy from one object to another, usually from high to low. Heat isn't something that you have, but something you exchange between two things. And it always happens because of an energy imbalance or an energy difference or temperature difference between the two objects. Once energy is transferred, it ceases to be heat. Now it's just energy that something possesses. Number 10, which amount of water on the hot stove takes less energy to be heated? Less water. And let's see. Temperature of an iron bar is proportional to the kinetic energy of iron atoms. The more energy they have, the more temperature you'd have. If you tripled the kinetic energy, it'll be 3 times as hot. And there was a question at the very end. And that's the review for all of that. Thanks for watching.